Okay, hello. So my name's Rhys. I work at the Financial Times as a principal engineer, and there's some text missing. But the title of the talk is a field guide to the Financial Times. So I'll be telling you about how we use Neo4j to create a guide to stuff at the Financial Times. So a bit more about me. I've worked in technology about 10 years. For most of that time, I was a front-end developer. But in the last few years, I've moved into tooling and back-end things, and I've ended up co-leading the reliability engineering team at the Financial Times. I'm also a lifelong birdwatcher. And that's what gave me the idea for the talk, that creating this guide to the Financial Times, which is one of the things our team was trying to do, is a bit like writing a good bird book. So a field guide is a book designed to help the reader identify wildlife. And that's kind of what we're doing at the Financial Times. We want to help people identify all the wild tech we've got running there. So today, I'm not going to tell you why all the slides are broken. I don't know the answer to that. But I'll tell you about why we need a field guide, how we use Neo4j and GraphQL to organize it, and how we go about filling in the details. And I'm really looking forward to finding out which other bits of my slides are missing. Right, now I'm very glad I've rehearsed this. So slide one, title one. Why do we need a field guide? Why do you need a book cover? So this is the Financial Times. This is ft.com. It's our flagship product. Somewhat unfashionably in this day and age, it both makes a profit and reports the news based on the facts. But that's not the only website we run. We also run dozens of other business and news websites. This is FT China, telling it like it is. And we run lots of other internal things. So in the top there, you see Fast Charts, which is a chart-making tool editorial use, which has just been published, made available to the public. We use lots of off-the-shelf things, like, for instance, Salesforce is used a lot. And there's lots of bespoke things, such as there's our change request API. So we have lots and lots of stuff running. We also still print a newspaper 6 days a week, and there's lots of tech involved in that, including quite a lot of really archaic stuff. And in addition to all this stuff, we're also the victim of the news cycle. So it's been quite exciting recently. So emails like this telling us to be careful, or notifications like that saying we need to delay printing the newspaper for a short amount of time, they add to the chaos. That's a picture of our operations team's general view. They look after our tech 24/7. And towards the left there, you see a dashboard with a tile for each of the services they need to keep an eye on. Now, in amongst all this, there's lots of really old, horrible tech. You hear legacy code used a lot. So I asked around to see if anyone had any great examples of when this has let people down. And this one's pretty good. So something that hadn't been documented since 1999, and which is worth hundreds of thousands of pounds. And I think the key phrase from this quote is that it's unowned and unknown, which is easier to type than to say. Then about 5 years ago, the amount of stuff we had to support, it really exploded. That wasn't an accident. So before, we were kind of old-fashioned how we did our tech. There was a lot of centralized planning, a lot of old-fashioned ways of building and releasing code. And what this kind of meant was we moved slow and we didn't really achieve much. There's lots of opportunities in the media industry to take advantage of new trends, and we weren't really, as a tech department, able to do that. So we had to change. One approach we adopted was microservices. The FT were one of the first big companies, I think, to really go to town on microservices. And this basically means instead of building one big service that does lots of jobs, you build lots of small things that interact with each other. And this, in theory and in practice a lot of the time, it makes it easier to respond to opportunities and iterate on ideas. Sarah Wells, one of our tech directors, I forgot to add it to the slide, but she recently did a really good talk about microservices at QCon, which is well worth checking out. Another thing we did at the same time was we liberalized our tech decision making. So moving away from centralized planning to giving teams the freedom to pick the best value tools for the job at hand. So we used to deploy to one big data center. That changed to deploying to whichever cloud you wanted. We mostly use AWS, but in theory, you're allowed to use anything you like. We had a standard deployment process called FT Platform. And now we choose what we like. We use a lot of Heroku, serverless, and other patterns. Most things were written in Java before. Now you just pick the language which suits the task. We use a lot of Node.js, a little bit of Python and Go. And before we used to sort of plan things and overthink things in advance, I think. And now what we tend to do is we just build stuff and see what takes. So to quote Matt, one of our tech directors again, the upside of this is teams left to their own devices and trusted to make responsible decisions will choose what is best for themselves and the business in the long term. Now, I was part of the teams that embraced this methodology at the time, so I really buy into this statement, but I'm just going to draw your attention to in the long term. Because this happens. Teams of people, they assemble to build the cool thing, and then they move on. And this can happen for a number of reasons. This is how legacy code becomes legacy code. So for instance, most of the images on most of our websites, they relied on a single service, which was built by one person, and they moved on, which left us with a service that no one knew how to support. We have a service which handles and sometimes rewrites every URL on ft.com. That was built by a team which existed for a short amount of time, and then it was disbanded, and that's a bit of a nightmare to support now. And we're a subscription paper, so our membership and sort of authentication services are really critical to our business, but part of that platform was built in a niche language that only one person knew, and we still have to support that. And there's lots of other examples as well. But even if, unlike us, you haven't gone for this kind of liberalizing how you do tech approach, 5 years is still a long time, no matter how your company's evolved. The things that everyone wanted to work on, they're not going to stay fresh forever. People will not want to work on them and not want to touch that really old code. The business's priorities will move on, and you won't get the resources you need to support something as you'd like, and of course, people leave. So to summarize all that, at the FT, we have to keep a lot of things running, and that's really increased over the last few years. And because of our liberalized tech decisions, the variety of stuff has increased as well. I think most companies can recognize at least some of that. And the reason we need a field guide is to help us find our way around that space. So we need to go from things being unowned and unknown to owned and known. So how do you use Neo4j and GraphQL to help us with this? Well, the team I help run has existed for about a year. When we were set up, we kind of had three priorities to improve the situation with how we were running our tech. We needed to reaffirm who owned which bits of tech. We needed to improve the information we had about what it was and why it existed, and also determine whether it's in a healthy state at any given time. So I'll mainly concentrate on the first two today. The main audience for this information is our operations team at the moment. So they are active 24/7. They cover the times when the rest of our engineers are not awake. They have a broad knowledge of all our tech, but they need accurate information on which sort of patterns they can apply to which kind of technical instance. And they also need to know who to contact if the information they've got doesn't fix the problem. Now, this isn't the first time I've tried to fix this problem of getting a guide of all the tech at the FT, but I've tended to suffer from some similar problems. They ended up being too inert, so people would add information and never update it, so it became out of date. They're too brittle in that if the organization changes slightly, lots of the information just ends up being inaccurate just overnight. And they're too discrete in that technology is full of connections, and our previous attempts were never really able to surface those connections and represent them correctly. Now, going back to the audience for a second, our operations team, they kind of ask this question: who can help me with this system? That's a natural thing to do when all your tiles are going red and you need to fix something. You need to know who can help me. So that means links between people and things end up being prevalent in these attempts to model it, which is really intuitive, but it is brittle because people move on and those links are very easily broken. And relational databases, they tend to push you down this route because, say, I am connected to a system via my role in a team, which is part of a subgroup of the company, and loads of connections. That's actually how it is in the real world, but a relational database will struggle to represent that chain. So it tends to get simplified down to some direct property or a connection via very few steps, which is kind of simple to think about and to model, but it's inaccurate, it's not a good picture of reality, and it's hard to maintain it over time. Graph databases, on the other hand, because they're designed to represent these connections, there's no need to simplify and abstract away these details that actually matter. So if I have a certain complex relationship to a system, we can represent it like that. We don't have to remove the details. So then the problem, which is about knowing who to contact, that changes from being the question of how can we assign someone to a system to being how can we connect someone through possibly quite a long chain. How can we connect them to the system? And then we have this question of what's the right level to connect something. So my advice for this is to model the stable stuff first. Even though everyone's asking about connections between people and things, that's not really easily maintainable. You may be able to make it accurate on a big sweep through the company, but that's destined to degrade over time. And unless you have some kind of stable foundation on which to build that fine-grained information, it's just destined to become inaccurate. So what we do, when we create a system, we give it a unique code, and any infrastructure related to that system, we tag it up with that code. If it's not tagged, it gets killed. And then in our graph database, we connect the system record with an ownership relationship to a team record. Now what that gives us, we have the system record, that's connected to the team that owns it, and you can follow the path up through parent teams until you get to a group, which is what we call our top level teams, and then that has a tech director. So what we have there is each bit of tech is connected to stable subdivisions of the organization. We don't have that many teams and they don't change very often. And that gives us a route all the way to the tech director, which is a senior person in the company who's ultimately responsible. So once we've got that stable foundation, we can then start adding the things we actually really, really care about. So our graph actually looks like that. So between systems and people, we have connections such as GDPR data owner or technical owner. And the beauty now is if that person moves on, we're not left hanging with kind of a record pointing to someone who's no longer there. We're able to follow it through to the team, and if necessary, the tech director to say, tell us who's responsible. The name of this system that stores all this information is called BizOps, which is short for business operations. And the idea is now we've got this stable foundation, we can just keep adding to it. We maintain a spreadsheet, which is called the list of lists. Anytime we hear about anyone in the tech department or anyone else in the company, maintaining a list of stuff that sounds interesting and sounds like it's worth connecting to the stuff we've already modeled, we put it in the list of lists with the hope that at some point, BizOps man will just go around and just eat it all up. Now, that's the ambition, to model as much of the company as possible. But we don't want to be a data warehouse where with this team, which are the gatekeepers to the data, and it's difficult for people to get access to. Instead, we want to be a free house where anyone could come in. So some principles to achieve this is we'd like to be self-service. We don't want people to have to ask us to get to the data. We don't want there to be power users. If you've got access to the data, we don't want you to then have to come and ask us to get additional access to the data. We want to make everyone a power user effectively. We want it to be extensible. So the idea that BizOpsMan is going to swallow the entire company. When people want to model new stuff, we want that to be natural. That's just part of the platform. We can add things to it. And we want it to be API first, so our developers can build stuff on top of it. But also, not everyone who's interested in the data is going to be a developer, so we want to provide UIs that give people access to the data. So starting from the bottom, we've got the data store. We want some API on top of it. So some options are REST. That's quite a common API paradigm. It's fine when you're interacting with a single record or a list of records of the same type. But once you start traversing records of different types, it becomes quite painful. You have to make lots of requests and glue them together. So we did consider having canned query endpoints. These basically mean you write a query with some placeholders in it, and the user makes a request, passing in some parameters. But this kind of takes it away from being a generic solution to being something that's limited by our imagination. And we're just making assumptions about what our users are going to want to do. And at some point, we'll be wrong, and we won't have built what they need. So that's not really future-proof either. So what we do use is GraphQL, which is a query language invented by Facebook a few years ago. GraphQL is a query language for APIs. It gives clients the power to ask for exactly what they need, not just the properties of one resource, but also smoothly follows references between them. So essentially, it's a querying language and schema designed for querying graph data. So Neo4j GraphQL.js is a library made by the Neo4j DevRel team. Our timing was quite good because we just started working on this project when they had only released this a few months before, and it's a very powerful tool. So most GraphQL APIs, they take a number of existing APIs, and they basically provide a gluing layer. So all the traversal following different endpoints, they glue that together for you so the end user doesn't have to do that themselves. But what this API does, it goes one step further. We've got a graph database at the bottom layer. So what this library does is it converts a GraphQL query into a Cypher query, so you can talk directly to the database. So what this looks like, on the left is a GraphQL query in one of the many off-the-shelf visual explorers of the data. And it looks like a hierarchical tree of data, which I think is how people think about this kind of data. And you run the query, and you get back data of the same structure. And under the hood, it writes that very complex Cypher query for you. And I love Cypher, but I don't really want to write queries like that every day. So it really takes a lot of the work away from us, which is good. Some big wins of it: it's user-friendly. The structure you put into the query looks like the structure you get out, and there's no limit to how much you can drill down the data. So it's very powerful and user-friendly. It's future-proof. As we add more and more stuff to our model, that will just appear in the GraphQL schema, giving people access to it. And it's really efficient. So instead of gluing together lots of API calls, there's a single API call, a single database query, which is quite an efficient database query because it only returns the properties you need, and that's just more efficient for our platform. On the downside, it is theoretically possible for our users to write very expensive queries. It's not happened yet, but we're conscious it could. GraphQL in general, it's kind of difficult to know what to do about caching because the user defines the query, so it's a bit difficult to know what the similarities are going to be between requests. It's not been a problem for us yet, but when we come to implement caching, there's going to be some tricky questions. And you can use GraphQL as a write API. I'm not convinced it's a massive improvement on REST, so we've stuck with REST for the time being for writes. So now we've sorted out the API layer, we want a UI. So what we've done is we have a custom schema which we maintain in YAML. That's used to generate the GraphQL schema that runs the API. It also provides lots of metadata, such as labels and flags and extended descriptions, which are passed into a suite of React components. And these, combined with a design systems library we have called Origami, mean we have a UI which just grows with the data. When we add new stuff to the database, the UI just expands naturally to represent that and to allow people to edit it. And it's also mobile friendly. So I remember a few years ago watching the film The Social Network, and there's a bit where he adds relationship status to the Facebook. He just types in a few lines of code, hits return, turns to his friend and goes, there, it's done. I remember at the time, sat there with my non-programming friends going, yeah, programming's not like that. It's not like that at all. But actually what we've built with this combination Neo4 and GraphQL and React, it is quite a lot like that. We have a system now where you change code in one place and it just propagates everywhere, which feels a bit magic. So the cool kids, they're calling this Grand Stack. By cool kids, I mean the Neo4j DevRel team. It's GraphQL, React, Apollo, and Neo4j database. There's a website, grandstack.io. If you need to expose the data in your graph to users, I thoroughly recommend looking into this. It's quite an intuitive and very powerful way to work. So to summarize all that, because of how we're thinking about the data and how we're modeling it, we have some confidence that the data in the BizOps won't just turn into an out-of-date data graveyard. A lot more confidence than we've had with previous systems. And through GrandStack, we're giving people unlimited access to the data for any person or machine. So that's the sort of the structure of our store, but obviously you put bad data in, you get bad data out. So how do we go about filling in the details? As I said before, it's not our first attempt. With graph databases, we've kind of solved the brittleness and discreteness problems, but there is a danger that the data will still be too inert. People won't update it. So the first thing to say is don't just rely on people's good behavior. I couldn't find a reference when writing these slides, which is a shame, but there's a really good article somewhere on the internet, I'm sure you can find it, where it basically says there's no such thing as human error. If people keep on making mistakes, then it's your processes and your systems which are to blame, and you need to work around that. So some approaches we have taken to improve the quality of data going in. We automate where we can. So if there's another system which is the source of truth for a kind of data, for instance, we have an API which knows all about our staff, and GitHub is a really good source of truth about our code bases, then we set up some jobs where that information is imported into the BizOps store on a daily basis. So BizOps isn't the source of truth, but it is where you can connect it to other things. We try and give people benefits for increasing data. So on the left, you can see Heimdall, which is a new monitoring tool we've been working on. If your team want a dashboard saying exactly what state your software is in at any given time, then you'll get it on your Heimdall dashboard, but only if your data is correct in BizOps. So that provides a real benefit for filling in data. We're not just asking people to give us information because we want it, we're asking them to give us information because they'll get something out of it. In a very similar way, while you can't exactly rely on people's good behavior, you can maybe rely on their competitiveness. So if you let people know how good they're doing, how that compares to their peers, and tell them what they can do to improve, then they will tend to do it. So we haven't launched this yet. We had a similar project a few months ago, which seemed to be successful, so we're putting a bit more effort into creating dashboards where people can see how good they're doing. And last, but definitely not least, We work a lot with UX and design. I think there's a tendency in tech, if you're building an external site with real customers, you bring in UX and design, 'cause it's all about conversions, and UX is all about smoothing the path, and you'll get more conversions. But that applies internally as well. Our conversions are, we want people to update their data, and UX can help with that. So it's quite gratifying sometimes. You get feedback like this, which is very nice. But translating that means people are enjoying updating the data, which means they're going to be doing more of it. But it's not just about the visual design. We go out and we interview our users, and we find out what's causing them problems in updating their data. We learn about what they're doing to work around this, and we learn about what they would like to do. And the end result of this is we're not building a system and then expecting them to come to us and update it in our way. Because we've learned about them, we can build stuff that fits in with what they're already doing. And there's a principle you often hear in design that good design is invisible. This doesn't just apply to physical objects or visual things. It applies to processes and workflows as well. So really try and get to know your users, and then you'll find out how to make it easy for them to update the data as you want them to. So as an example, our runbooks are the kind of basically the documentation that our operations team go to find information about a system. So that information, So when a system changes, that is caused by source code changes in GitHub. But to update the runbook, people are expected to come to the BizOps admin screens and type something in there. So they're not tied together in any kind of unified way, and they're bound to get out of step eventually. So what we're now working on doing is maintaining runbooks in a file in the code repository. And in this, whenever we detect a production release has happened, we pull this content into this structured content into the BizOps database, which drives a kind of a new publish of the runbook. And on top of that, we can now start building extra integrations with GitHub and Slack and things like that to really drive up the quality of what people are writing. And that doesn't just apply to technical information. So in small ways, we're starting to work more with GDPR, with our GDPR teams, to try and make this network of data underpin how requests to do with GDPR happen. For our security team, if we kind of improve the processes that get information about the way all our systems are connected together, that will improve how we triage security incidents. And if we integrate with our levers process, that'll have lots of benefits. So the more benefits we give people, the more likely people are to give us the data we want, which can then be used by teams other than them. So to sum up everything, legacy code comes to us all. You may think you're in a startup that's going to be young forever, but that's not true. Documenting your legacy code can really help with that. So graphs enable more powerful modeling of your tech infrastructure and more things besides. And as a layer on top of that, GrandStack makes you feel like the film version of Mark Zuckerberg, which possibly might be a bit better than the real world version. And finally, your data won't update itself, so use user experience and other feedback loops to try and help people keep it fresh. Thank you.